Good morning, students. Today's topic we are going to see is that capacitive type of transducers, and sensistors also. Okay, please tell me whether my screen is visible or not. Is it visible? Is it visible?
Yes, sir.
Okay, thank you. Today's topic is capacitive type of transducer. In this capacitive type of transducer, the basic we know the what is the formula for capacitance. From that formula only, we will derive the different shapes of capacitive transducers are there. Different shapes as well as different what is the area of the plate, what is the area of the plate, what is the distance between the plate, what is the dielectric of the capacitive transducer. Depends upon these parameters, this transducer is going to be operated. Okay, here a capacitor consists of two conductors here, that is plates, that are electrically isolated from each other by a by non-conductor, that is dielectric medium. When the two conductors are at different potentials, when the two conductors, that means two plates are at different potentials, that is voltages, the system is capable of storing an electric charge. That system means entire capacitive capacitive type of transducer is able to store some charge. The storage capability of a capacitor is measured in farads. Okay, the principle of operation of capacitive transducer is based upon the equation for capacitance of a parallel plate capacitor is shown in figure. Next upcoming figure will be there, that I will show you. Capacitor C is equal to epsilon A by D. This is the basic formula, where A is the overlapping area of the plates. D is the distance between the two plates. This is the area, is the units is meter square. Distance is, its units is meters. Epsilon is permittivity, that is dielectric constant. Okay, farad per meter. The capacitance is measured with bridge circuits. The output impedance Z. The output impedance Z of a capacitive transducer is given by Z is equal to 1 by 2 pi Fc, where Z is impedance, F is frequency, that frequency 50 hertz, and C is capacitance, like that. Okay, and this is the capacitor type of transducer. This is one plate and this is another plate. In between, dielectric medium. This is the top plate, this is the bottom plate. In between, dielectric medium. We can define it as the flow of current is given by I is equal to dq by dt. Here, C is equal to epsilon A by D, where epsilon is permittivity, that is constant. A is area of plate, D is distance between the plate. In terms of voltage, it is given by V is equal to Q by C. V is the voltage between the plates, Q is charge on a plate, C is capacitance. In terms of current, I is equal to C dV by dt. I is current, dV is change in the voltage per unit time, C is capacitance. In this way, we can find out the capacitance, voltage, and current from these different formulas. And this is the first one is, this is the variable capacitor transducer variation. First one, variable capacitor transducer variation. First one is area area of overlap, the overlapping of the two plates, area of the overlap. And second one is distance between the distance, second one is distance between the plates. And third one is dielectric, amount of dielectric between plates. This is the normal one. I'm going to use two plates here, whereas a differential capacitor transducer I'm going to use three plates, like that. Differential capacitor transducer varies capacitor ratio by changing area of plates between three plates, distance between plates between three plates, and dielectric between plates. This is the differential capacitor transducer, and this is the normal variable capacitor transducer. First one is area, next one is distance, and the third one is dielectric. We will say here all the differential. This is the third one. They are talking about the third one. All the differential devices have three wire connections rather than two wires. అంటే మనం త్రీ ప్లేట్స్ యూస్ చేస్తున్నాం కదమ్మా, అందుకని త్రీ వైర్స్ కనెక్ట్ చేస్తున్నాం అనమాట. వన్ వైర్ ఫర్ ఈచ్ ఆఫ్ ది ఎండ్ ప్లేట్స్ అండ్ వన్ ఫర్ ది కామన్ ప్లేట్స్. టూ ప్లేట్స్కి టూ వైర్స్ అండ్ వన్ ఫర్ ది ఒక ప్లేట్ ఏమో కామన్ గ్రౌండ్గా తీసుకుంటాం అనమాట. యాజ్ ద కెపాసిటెన్స్ బిట్వీన్ one of the end plates and the common plate changes, the capacitance between the other end plate and the common plate also changes in opposite direction. ఒక ప్లేట్కి కామన్గా ఉన్నదానికి ఒక డైరెక్షన్లో ఉంటుంది. కెపాసిటెన్స్ పాజిటివ్ వచ్చింది అనుకోండి, ఇంకొక డైరెక్షన్లో ఆపోజిట్ డైరెక్షన్లో ఇంకొక చేంజ్ ఇన్ ద వాల్యూ వస్తుంది అనమాట. అది in general, the output impedance of a capacitive transducer is high. The capacitive transducer works on the principle of change in the capacitance of the capacitor. This change in the capacitance could be caused by change in overlapping area of the plates, change in the distance between the plates, and change in the dielectric constant theta. ఆ కెపాసిటెన్స్ అనేది త్రీ టైప్స్లో మనం చేంజ్ చేయొచ్చు అనమాట. అదేంటి? డిస్టెన్స్ డిస్టెన్స్ బిట్వీన్ ద ప్లేట్స్, ఏరియా between the plates, and dielectric constant between the plates, that is epsilon. In most of the cases, the above changes are the above changes are caused by the physical variables such as displacement, force, or pressure. Variation in capacitance is also there when the dielectric medium between the plates changes, as in the case of measurement of liquid or gas levels here. We can measure by using this capacitor transducer, we can measure the liquid or gas levels also. That is application. Therefore, the capacitor transducers are commonly used for the measurement of linear displacement, that is change in the capacitance due to the change in the overlapping area of the plates, change in capacitance due to the change in the distance between the two plates, change in capacitance due to the change in dielectric constant between the two plates. Only these three parameters we are going to focus. First one, first one, transducers using change in area of plates. That is, examining the equation for capacitance, it is found that the capacitance is directly proportional to the area, capital A of the plates. Thus, the capacitance changes linearly with change in area of plates. Hence, this type of capacitive transducer is useful for measurement of moderate to large displacement. We are going to use this type of transducer is moderate to large displacement. We are going to use this transducer. Say that maybe 1 mm to several centimeters, 1 mm నుంచి several centimeters వరకు we can make the displacement change. The area changes linearly with the displacement and also capacitance here. For a parallel plate capacitor, the capacitance is given by epsilon A by D. Epsilon A by D. First one come ఈ diagram కి C is equal to epsilon A by D. That is epsilon L W by D. That is converted into epsilon L W by D, where L is length of overlapping part of plates. Overlapping part of plates. Where L is length of overlapping part of plates, that is meters, and W is width of overlapping part of plates. Okay, and I am going to take the same equation and the sensitivity I am going to convert that equation in terms of sensitivity as dou C by dou L. That is change in the capacitance with respect to length. That is given by here. Here dou L is there. Therefore, that equation is going to converted epsilon W by D. This is the sensitivity equation. Any equation can be converted, and it can be the sensitivity of the transducer can be identified like this. That is dou C by dou L. The sensitivity is constant, and therefore there is a linear relationship between the capacitance and displacement. This type of Capacitor transducer is suitable for measurement of linear displacement ranging, that is 1 to 10 centimeters. This is the 1 to 10 centimeters we can displacement of the transducer may takes place. This is very heavy type of displacement only. The accuracy is high at the accuracy is very high, as that is 0.05%. Okay, the deviation part is very low, accuracy is very high. Next one, the second one, that is change in distance between the plates. Here again, this is from the second diagram. This is from second diagram we are talking about, that is, this figure shows the basic form of capacitive transducer employing change in distance between the two plates to cause the change in capacitance. One plate is fixed here, and the displacement to be measured is applied to the other plate, which is movable. Since the capacitance C varies inversely as the distance d between the plates, the response of this transducer is not linear. The response of this transducer is not going to be linear here. Thus, this transducer is useful only for the measurement of extremely small displacement. Is the distance between the plates the intended extremely small displacement ని measure చేయటం కోసమే యూస్ చేస్తాము ఇది. Hmm? Then this sensitivity is given by this formula, that is minus epsilon a by d square. Okay, sensitivity S is given by dou c by dou L. The sensitivity of this type of transducer is not constant but varies over the range of transducer. The relationship between the variation of capacitance with the variation of distance between the plates is hyperbolic in nature and is only approximately linear over the small range of displacement. The linearity can be closely approximated by the use of this linearity can be closely approximated by the use of piece of dielectric material like mica. We are going to use this mica having the high dielectric constant, such as thin piece of mica can be used for the high dielectric constant sake. Okay, and third one we will see, that is transducer using the changing dielectric constant between the plates, and I am talking about this one, dielectric constant, this one. Here, if the area of and the distance between distance d between the plates of the capacitor remains constant, capacitance will vary only as a function of the dielectric constant epsilon of the substance filling the gap between the plates. If the space between the plates of a capacitor is filled with an insulator, that means dielectric constant as insulator, the capacitance of the capacitor will change compared to the situation in which there are vacuum between the plates. The change in capacitance is caused by the change in the electric field between the plates also. The value of the dielectric constant is initially set by design in the choice of the dielectric material and used to make the capacitor. Many factors will cause this dielectric constant epsilon to change, and this change in dielectric constant will vary from different materials. Different materials కి different dielectric constant ఉంటుందన్నమాట. అందుకని the change mainly depends upon the whatever the material we are going to use. The major factors that will cause a change in dielectric constant are, మన dielectric constant లో చేంజ్ ఓవర్ తీసుకురావాలంటే that may be because of moisture, voltage, frequency and temperature. The dielectric constant of a process material can change due to the variation in temperature, moisture, humidity, material bulk density and particle size, etc. The dielectric constant epsilon in the basic formula is the effective dielectric constant of the total space between the electrodes. This space may consist of dielectric material. That space may consist of dielectric material. Material may have this air and even moisture also. Okay. The figure shows that how in a capacitor the position of the dielectric is varied. To vary the capacitor, the physical variables such as displacement, force, or pressure can cause the movement of dielectric material in the capacitance plates, resulting in the change of effective dielectric constant. వీటిలో ఏదైనా సరే మనం డిఫరెంట్ డిఫరెంట్ పారామీటర్స్ ఉన్నాయి కదా మనం. ఇది డిస్ప్లేస్మెంట్ కానీ ఫోర్స్ కానీ ప్రెషర్ కానీ కాజ్ ద మూమెంట్ ఆఫ్ డైఎలక్ట్రిక్ మెటీరియల్ మూమెంట్ని కాజ్ చేస్తాయి. ఆ కాజ్ చేయటం వల్ల ఏంటంటే చేంజ్ ఇన్ ద కెపాసిటెన్స్ అనేది జరుగుతుంది అనమాట. And major advantage of capacitive transducers are that they require extremely small forces to operate them, and hence are very useful for use in small systems also. They are very extremely sensitive and require small power to operate them. Owing to their good frequency response, they are very useful for dynamic studies also. Disadvantages of capacitive transducers include the non-linear behavior on the account of edge effect. Non-linear behavior ఉండటం వల్ల ఏంటంటే ఎడ్జ్ ఎఫెక్ట్ అనేది జరుగుతుంది అనమాట. దట్ ఎడ్జ్ ఎఫెక్ట్ అండ్ ద ఎఫెక్ట్ ఆఫ్ స్ట్రే కెపాసిటెన్స్ ఆల్సో, ఎస్పెషల్లీ వెన్ ద ట్రాన్స్డ్యూసర్ హ్యావ్ ఎ లో వాల్యూ ఆఫ్ కెపాసిటెన్స్. దేర్ ఫోర్ గార్డ్ రింగ్స్ మస్ట్ బి యూజ్డ్ టు ఎలిమినేట్ దిస్ ఎఫెక్ట్. ఆ ఎడ్జ్ ఎఫెక్ట్ని తీసేయాలంటే వీఆర్ సపోజ్ టు యూజ్ సమ్ గార్డ్ రింగ్స్ must be used to eliminate this effect. The metallic parts of the capacitor transducer must be insulated from each other in order to reduce the effects of stray capacitances. The frames must be earthened. ఆ ఫ్రేమ్స్ కూడా మనం ఎర్త్ చేసుకోవాలన్నమాట, లైక్ గ్రౌండింగ్ లైక్ దట్. ఓకే. The capacitor transducer can be used for measurement of both linear and angular displacement. The capacitor transducers are highly sensitive and can be used for measurement of extremely small displacement down to the order of molecular dimensions, that is zero point 0.1 into 10 power minus 6 mm. That much small amount is also possible to measure. On the other hand, they are used for the measurement of large displacement up to about 30 meters also, as in the aeroplane altimeters. That application is aeroplane altimeters is possible, as well as very small means molecular dimensions measurement is also possible. This much zero point 0.1 micrometer like that. The change large distances up to 30 meters in aeroplane altimeters. The change in area method is used for the measurement of displacement range from 10 to 100 millimeter. Capacitive transducer can be used for the measurement of force and pressure also. The force and pressure to be measured are first converted to force and pressure measurement lo first converted, that is going to be first converted to displacement, and then which causes the change in capacitance. Capacitive transducer can also be used directly as pressure transducers in all those cases where the dielectric constants of a medium changes with pressure. They can be used for measurement of humidity in gases and measurement and moisture and content in soil or fruit product, etc. Okay. There are. This is about three type of transducers we have seen. That is transducers using a change in area of plates, transducers using change in distance between the plates, transducers using change in dielectric constant. Okay. And we will see the different types of capacitor transducers. That is according to the structure of the capacitor transducer, there are four types we can discuss here. That is parallel plate capacitor with rectangular plates, parallel plate capacitor with rectangular plates, cylindrical capacitor transducer, semicircular parallel plates, change in the dielectric between the parallel plates. In this I am going to use two rectangular type of plates. I am going to use one plate is going to be fixed and another plate is going to be movable. If we move this one, if we move this one capacitance, the distance between the plates, the width, this is the width and this is the length. By using the basic formula, this is the basic formula, that is C is equal to epsilon into A minus Wx by D. Wx by D, this is the width, permittivity, area, and by D distance between the plates. Here, here First one, this is also a flat type of capacitor transducer. In this type of transducer, one plate is fixed and another plate is movable. By this variation, the distance d or area a can be varied. We can vary this distance as well as area of the plates. Distance and area of the plates we can vary here. This results in the capacitance value is going to be increase or decrease. If we move this plate in this direction, capacitance is going to be increases here by this formula. Distance is going to be small. That's why capacitance increases. If we move this one, if we move the movable plate in this direction, distance between the plates is going to be very high. Therefore, capacitance is going to be small, decreases. If area capital A varies and the capacitance value C would be capacitance value would be when the plates are having the distance of small x like that. Okay. Here another type is there, that is cylindrical capacitor transducer. Consider the length of the cylinder is capital L. This is the length of the cylinder is capital L. Its permittivity is epsilon and the radiuses are there R1 and R2. That formula, that capacitance formula is given by 2 into pi epsilon naught epsilon r, that is epsilon L length, and log into R2 by R1. This is the formula for cylindrical type of capacitor transducer. And next one is semicircular type of capacitor transducer. This type will provide the highest capacitance value when the two capacitance plates are overlap each other. ఈ టూ కెపాసిటెన్స్ ప్లేట్స్ని ఓవర్లాప్ చేసాం అనుకుంటాం, అప్పుడు మనకి మ్యాక్సిమం అమౌంట్ ఆఫ్ కెపాసిటెన్స్ వాల్యూ వచ్చింది అనమాట. దిస్ ప్లేట్ ఈస్ ఫిక్స్డ్, దిస్ ప్లేట్ ఈస్ గోయింగ్ టు బి ఫిక్స్డ్, అండ్ దిస్ ప్లేట్ ఈస్ మూవబుల్. It may form some angle, it may vary with an angle theta, and its radius is smaller, and it is going to be grounded. These are preferable when the circuit requires the maximum capacitance. ఇవి ఈ సెమీ సర్క్యులర్ టైప్ ఆఫ్ కెపాసిటెన్స్ మనం ఎప్పుడు యూస్ చేస్తామంటే మనకి మ్యాక్సిమం అమౌంట్ ఆఫ్ కెపాసిటెన్స్ కావాలి అన్నప్పుడు వీఆర్ గోయింగ్ టు యూస్ దిస్ సెమీ సర్క్యులర్ type of capacitor transducer. In this capacitor, in this type of capacitor transducer, area is given by pi r square by 2. This is the basic formula, we know this one. And the capacitance C is given by pi epsilon pi r square by 2d. This is the formula for capacitance for a semicircular type of capacitor transducer. Epsilon pi r square by 2d. And next one is and fourth one is change in dielectric medium between the parallel plates. అంటే ఫస్ట్ చూసాం కదమ్మా డైఎలక్ట్రిక్ మీడియం డయాగ్రామ్, ఆ డయాగ్రామ్ని దీనికి అప్లై చేసుకుంటాం అనమాట. When the dielectric medium varies between the two parallel plates of the transducer, then also variations of capacitance of the transducer may take place. Therefore, capacitance C is given by epsilon naught into epsilon 1 into L1 into W. That is the length and the width, plus epsilon 2 into L2 W by D. D, where L1 and L2 are indicating the length of the first and second plates, W indicates the width of the plates, D indicates the distance between the plates. Advantage of this capacitor transducers are, ఇప్పుడు మనం చూసిన ఈ టైప్ ఆఫ్ కెపాసిటర్స్లో ఈ టైప్ ఆఫ్ ప్యారలల్ ప్లేట్ కెపాసిటర్స్లో దిస్ ఈస్ ద ఫార్ములా. జస్ట్ know this formula and just know this formula. cylindrical type of capacitor type of transducer, semicircular type of capacitor transducer. దీన్ని ఏమన్నా ఎగ్జామ్లో ఏదైనా చెప్పమంటే మీరు ఈ రెక్టాంగులర్ టైపు, ఈ సెమీ సర్క్యులర్ టైపు బాగా ఎక్స్ప్లెయిన్ చేయడానికి ట్రై చేయండి చాలు. సెమీ సర్క్యులర్ టైప్, ఓకే. అండ్ సి ఈజ్ ఈక్వల్ టు, ఇవి నేమ్ చేయండి మెయిన్గా. ఈ టూ టైప్స్ ఎక్స్ప్లెయిన్ చేయడానికి ట్రై చేయండి, రెక్టాంగులర్ అండ్ సెమీ సర్క్యులర్. దోస్ ఆర్ ఇంపార్టెంట్. Advantages, next one is advantages. Capacitor transducer advantages. These transducers offer a high input impedance, so the loading effects value will be very low. The frequency response of these transducers is extremely high. These transducers are highly sensitive, consumes low power. Transducers are high resolution. It is having the high resolution. Disadvantages of this transducer is high output impedance. Because of the high output impedance value, a complicated circuit is needed to measure the output. High input impedance ఉండటం వల్ల ఏంటంటే circuit may be complicated, and we need to measure the output value from that circuit. The output circuit needs to be powerful, maintain this high impedance value. These transducers exhibit non-linear behavior due to the edge effect. ఈ ఎడ్జ్ ఎఫెక్ట్ ఉండటం వల్ల ఏంటంటే నాన్ లీనియర్ బిహేవియర్ కూడా దానిలో మన ట్రాన్స్డ్యూసర్ గోయింగ్ టు కమ్ అక్రాస్. దీస్ ఆర్ టెంపరేచర్ డిపెండెంట్. ద ఎక్స్టర్నల్ టెంపరేచర్ వాల్యూస్ కెన్ ఎఫెక్ట్ దిస్ ట్రాన్స్డ్యూసర్ కెపాసిటెన్స్ వాల్యూ ఆల్సో. Okay. Here, applications of a capacitor transducer, we can measure temperature, displacement, and pressure also. Okay, the transducer have applications in the field of linear and angular displacement with the sensitivity factor. One of the best application of this transducer is to find the humidity level. As the humidity value changes, the capacitance value of the transducer also changes. By this value, we can measure the change in the humidity. The variable capacitance, uh, the variable capacitance pressure transducer is applicable to find the pressure variations by using the variable capacitance. Thus, the capacitive transducers are useful for converting one form of energy into another form of energy by taking the change in the capacitive value. These are the passive transducers because this requires external power to operate them. And with the help of these transducers, we can measure the pressure, temperature, and displacement also. This is these are the applications of a capacitive transducer. We will see the one application, that is capacitance pressure sensor. Variable capacitance pressure sensor. Variable, this is the frame, this is the frame, and this is the dielectric. Let us assume that it has dielectric. This is the static plate, insulating material, rare cavity. This is the extreme end cavity, that is rare cavity termination, and a deflecting diaphragm. This is the deflected diaphragm. This is the deflected diaphragm, and let it be. This is the A. This is the A, and this is the Y. Y. What is this A and Y? We will think. Pressure is applied here. Pressure P is applied. Undeflected diaphragm means there is no. This is Y portion is going to be very small. Okay. This is about this is the entire frame. We can call this as the entire frame. The entire apparatus is enclosed with this frame. Okay. Here, containing a diaphragm instead of one of the fixed plates, the dielectric material is air here. The flexible diaphragm is pulled. The flexible diaphragm is going to be pulled, uh, taut, but bends into the curvature on pressure. It is going to be bend here. It is going to be bends into the curvature on pressure. Whenever we are applying some pressure here, this is going to be bend here. Okay. For any radius small r, the deflection y is given by, here the deflection y is given by this formula. This formula, 3 by 16 into 1 by v square by e t cube into a square minus r square whole square by p. A is area, r is radius, and p is the pressure, e is and v is the Poisson's ratio, and E is the Young's modulus of elasticity, like that. Okay. So A is the radius of the diaphragm, T is the thickness of the diaphragm, and E is the Young's modulus of elasticity, V is the Poisson's ratio. The increase in the capacitance is given by మనకి ఇది డిఫ్లెక్షన్ టర్మ్ అమ్మ. నెక్స్ట్ ద చేంజ్ ఇన్ ద కెపాసిటెన్స్ వాల్యూ, ద ఇంక్రీజ్ ఇన్ ద కెపాసిటెన్స్ వాల్యూ ఇచ్చామనుకోండి, అప్పుడు ఎట్లా అవుతుంది, దట్ ఈస్ డెల్టా సి బై సి, that is equal to delta c by c, that is equal to 1 by v square into a power 4 by 16 e dt cube, dt cube into capital P. This is the increase in the capacitance is given by the formula. This is the change in the capacitance value like that. నెక్స్ట్ వన్ సి ఈస్ ద కెపాసిటెన్స్ అట్ జీరో ప్రెషర్. ఒక జీరో ప్రెషర్ అనుకుంటాం, మనం అసలు ప్రెషర్ అప్లై చేయలేదు. అప్పుడు కెపాసిటెన్స్ వాల్యూ ఈస్ గివెన్ బై సి ఈజ్ ఈక్వల్ టు ఎప్సిలాన్ పై ఏ స్క్వేర్ బై డి. దిస్ ఈస్ ద సింపుల్ ఫార్ములా, పై ఏ స్క్వేర్ బై డి. దిస్ ఈస్ ది whenever I am not going to apply any sort of pressure to this transducer, then this is the formula, C is equal to epsilon pi a square by d. This is same principle used in capacitor microphone also. This is the principle is going to be used in microphones, which is going to convert the electrical signal to sound signal like that. Hmm. Enclosing in a airtight container in a metallic diaphragm which moves to the left when the pressure is applied, to the chamber, and to the right when vacuum is applied. ప్రెషర్ అప్లై చేసాం అనుకోండి, ప్రెషర్ అప్లై చేసినప్పుడు ద మూమెంట్ ఇన్ ది క్యావిటీ మే టేక్స్ ప్లేస్ హియర్, ద మూమెంట్ ఇన్ ది చాంబర్ ఆర్ క్యావిటీ మే టేక్స్ ప్లేస్. That movement is going to be right direction when the vacuum is present, which moves to the left when the pressure is applied to the chamber, and to the right when vacuum is applied. The diaphragm is used as one plate of a వేరియబుల్ కెపాసిటర్. ఆ డయాఫ్రమ్ మేము ఒక ప్లేట్ ఆఫ్ ది కెపాసిటర్లా తీసుకుంటాం అనమాట. అండ్ ఇట్స్ డిస్టెన్స్ ఫ్రమ్ ది స్టేషనరీ ప్లేట్ టు ఇట్స్ లెఫ్ట్ యాజ్ డిటర్మైన్డ్ బై ద ప్రెషర్ అప్లైడ్ టు ది యూనిట్ డిటర్మైన్స్ ది కెపాసిటెన్స్ బిట్వీన్ ద టూ ప్లేట్స్. ది ద మానిటర్ indicating the pressure equivalent of the unit capacitance by measuring the capacitance reactance to the AC source voltage. Here, uh, this is about the movement in this diaphragm may takes place whenever the vacuum is there. Then there is no movement, that is going to be no movement will takes place whenever I am applying some I am going to apply some pressure is applied to the chamber, then the left movement will takes place. And అంటే వాళ్ళు రైట్ లెఫ్ట్ అని చెప్తున్నాడు కదనమ్మా, దెర్ ఈస్ అ మూమెంట్ ఇన్ ది ఛాంబర్ అని చెప్పి చెప్పండి చాలు, లెఫ్ట్ రైట్ అని చెప్పొద్దు, యూ మే గెట్ కన్ఫ్యూజ్డ్. ఆ డయాఫ్రమ్ మొత్తాన్ని ఒక ప్లేట్ అనుకుంటున్నాం, వన్ ప్లేట్ ఆఫ్ ది వేరియబుల్ కెపాసిటర్ అనుకుంటున్నాం. డిస్టెన్స్ బిట్వీన్ ది ఈ డయాఫ్రమ్ మొత్తాన్ని ఒక ప్లేట్ అనుకుంటున్నాం, దీన్నేమో ఒక స్టాటిక్ ప్లేట్ అనుకుంటున్నాం అనమాట. అండ్ దిస్ ఈస్ ది డైఎలక్ట్రిక్ మెటీరియల్. దిస్ ఈస్ వన్ ప్లేట్ అండ్ దిస్ ఈస్ అనదర్ ప్లేట్. This is about capacitive pressure transducer. And the final topic is sensistor. Sensistor is a resistor whose resistance changes with temperature. The resistance increases exponentially with temperature, that is the temperature quotient is positive for the sensistor. Example 0.7% per degree centigrade. Sensistors are used in electronic circuits for compensation of temperature influences, or as sensistors of temperature for other circuits also. Sensistors are made by using very heavily doped semiconductors, so that their operation is similar to the positive PTC type of thermistors. ఈ సెన్సిస్టర్ PTC type of thermistor లా యాక్ట్ చేస్తుంది అనమాట. ఆల్మోస్ట్ it is going to be heavily doped semiconductor. It acts as PTC type of thermistor. However, very heavily doped semiconductors behaves more like a metal. హెవీగా డోప్ చేసినప్పుడు ఏంటంటే ద చార్జ్ క్యారియర్స్ ఈస్ మోర్, దేర్ ఫోర్ ఇట్ కెన్ బి యాక్ట్స్ యాజ్ ఏ కండక్టర్ ఆల్సో. దేర్ ఫోర్ కండక్టర్, ద ఎగ్జాంపుల్ ఫర్ దట్ కండక్టర్ ఈస్ మెటల్. అండ్ ద రెసిస్టెన్స్ చేంజ్ ఈస్ మోర్ గ్రాడ్యువల్ దాన్ ఇన్ ద కేస్ ఆఫ్ పీటీసీ థర్మిస్టర్. ఆ రెసిస్టర్ వాల్యూ అనేది ఎక్కువగా ఉండొచ్చు అనమాట వెన్ కంపేర్ టు ది సెన్సిస్టర్ యాజ్ వెల్ యాజ్ థర్మిస్టర్. సెన్సిస్టర్ Sensistor application. Sensistor may be placed in parallel with R1 or in parallel with RE. This is the diagram. Normally, this is self-biased circuit R1, R2, RL, RE, and the sensistor is going to be placed in parallel with R1. Okay, and the capacitor is also maintained. This is the some compensation technique we have seen this one. Compensation techniques లో మనం థర్మిస్టరు సెన్సిస్టరు మనం చూసాం ఆల్రెడీ ఈడీసీలో. ఈడీసీ సబ్జెక్ట్లోది ఇక్కడ అప్లికేషన్ చెప్తున్నాం. అది సెన్సిస్టర్ రెసిస్టెన్స్ is RS. That is the point. As the temperature increases, the sensor may be placed in parallel with R1 or in parallel with RE. As the temperature increases, the resistance of the parallel combination thermistor and R1 increases and their voltage drop also increases. The decrease the value of voltage drop across R2. This decreases the value of voltage drop across R2 due to the decrease of this voltage. The net forward emitter bias decreases, and as a result of this, IC decreases. The output collector current is going to be decreases. ఇక్కడ ఉన్న వోల్టేజ్ లెవెల్స్, ఇక్కడ ఉన్న వోల్టేజ్ లెవెల్స్, ఇక్కడ ఉన్న అవుట్పుట్ దగ్గర ఉన్న వోల్టేజ్ లెవెల్స్ అన్నీ చూసుకొని మనం ఫైనల్గా ఏం చేస్తాము, కలెక్టర్ కరెంట్ని డిక్రీజ్ చేసుకుంటాం. ఎందుకంటే థర్మల్ రన్ అవే జరగకుండా. అది జస్ట్ here IC decreases. Hence, by employing the sensor, the rise in the collector current, which is caused by the increase in the value of IC naught, VBE, and beta due to the temperature, get controlled. And the extension for this point is we can avoid the condition of thermal runaway. Okay. By this topic, we have completed the unit 5. Unit 5. Please go through this one. Please go through the material once again. I will share the material in your group by this evening. Please go through this one.